Our next speaker is my former colleague from TU Dresden, Michael Engelmann. Yes, go ahead. So Michael is a professor at the Institute of Building Constructions at TU Dresden. And today he will tell us something about load-bearing capacity of historically produced mouth-blown glass. I'm curious.
Thank you so much, Jagoda. Welcome everybody this afternoon. I know it's tough after a long night and after lunch, but I guess I will get you some interesting info about the load-bearing capacity of mouth-blown glass. And I will give you, after this presentation, you will probably have an indication of what can you expect from historical produced mouth-blown glass in comparison with, I would say, not so much traditional, but current float glass products. This study was raised together with colleagues from University of Bamberg. And if you probably know the city of Bamberg, it's a historical city. It's World Heritage, and it has really many historic facades that are being restored recently. Well, because this brings in some money, and they are actually using it for optical restoration and also energy-efficient restoration of facades. And especially for the buildings from the 19th and 20th century, you will find those nice facades with the small windows in there. And you see when you doing it correctly, facades will still maintain their original character by looking into correct use of windows and window frames. But just across the street from this building, you will also find examples like this here. This facade has also been refurbished. You see the inner sections look brand new, and the windows also have been replaced in this case. And I think it's a pity that we are losing lots of characters of those facades when we are restoring them in this way, just maintaining part of the shape of the original frames, actually totally changing the frames, or, well, removing them almost completely. So I guess we have lots of historical building, of heritage building that we want to conserve, and we have to focus on the actual correct use of frames in there. But we also have to look into the actual glass, and I want to show you this in a specific example. This is Seiner Hütte in Bendorf near Koblenz. Just a specific example I chose. The original building here was used to cast iron. It was built in the 1770s, and of course it was changed a lot after some time. And this is the front facade of the main hall from the I wrote this down, 1830s. So it's about 200 years old now. And well, this building was used to cast iron. And in the 1920s, the building was not used anymore. They stopped doing this. But 100 years later, so in 2010, the building turned to be a heritage building, and they received some money for refurbishing of the facade. And this is what the facade looks like today. You see the iron facade, which I think is really nice from the engineering perspective when you see those shapes and those small details. The iron itself was restored. You have totally new surfaces, and it looks brand new right now. They even replaced the door in here, so the original door is back, replacing the wooden door that was in there before. But they also replaced the glass. And we see it in a direct comparison when you put those two buildings, or the same building, but from two different times right next to each other. You see the original one with the original glass, which was produced, of course, before the age of float glass. So basically mouth-blown glass. And you see the original character of this facade. It's a bit shady. It doesn't shine so much compared with the float glass option. The float glass in some places is very reflective. You see what's happening in front of the building, and in some places it's very transparent, so you see what's happening inside of the building. And I think just replacing the glass here really changes the appearance and the characteristic of the facade. So again, we are losing some parts of the original character of the building. There are many reasons for this to happen. Well, first and foremost, many architects and authorities, of course, do not have too much in-depth knowledge about the glass. Everybody is living on a really short time scale and have some schedule to follow. So it's hard for them to actually retrieve the information they need to do an historical refurbishment of this. And this is when our research came into play, as we already did some studies, and Jagoda was also pretty much involved here. So we already looked into several buildings and into the original available glass in buildings during a couple of time. And we did studies, as you always have seen from other presentations as well. We looked into what kind of structures do we find in those buildings. So what kind of windows, what kind of window sashes, what kind of window constructions, what types of glass do we find in those buildings, what is still left from the original building and what has been renewed. Of course, you can measure the glass, and we also looked into strength. Today I want to give you an indication of what you can expect for mouth-blown glass in this combination, because at some point, but not for this building here, the question is raised, how can we remodel the building correctly? And, well, of course, how much will it cost? Because when you think about buying mouth-blown glass, it will be extremely expensive. So the idea was raised, or I raised the idea, hey, why don't you remove the glass, refurbish the frame, and put in the glass back again after renewing it a bit, which is, of course, a traditional, or not a traditional, it's a reuse case. And I think it's a reuse case that is triggered not only by the fact that we can save lots of carbon in there, but it's also triggered just because of economic reasons. Because new glass would be extremely expensive. Just reusing the original glass is a valid idea to restore the building. That's why, well, when you try to do this, of course, the first thing that hits you is building laws and building authorities. They are asking you, okay, you want to use this glass again? Where's your CE marking? Can we actually use it? Is it safe? And of course, you don't have this. And we started a study on not on how to get this, but on giving us an indication of what is needed in order to do this. So we started a little study with 66 samples. So this is a bit of a scope. We looked into the quality of the glass. So how many bubbles do we find in mouth-blown glass? Where are they located? And what's their size? We looked into the edges. How can you produce the edges? And what is, of course, the effect of edge treatment to the strength? We looked into the thickness of the glass, because the thickness is very, of course, strongly correlated to the optical effects we find in the glass. The glass looks differently, and one of the major reasons for having different reflective properties is a change in thickness of the glass. Then, of course, we looked into strength. We did 4-point bending tests, and we also looked into, can we thermally temper the glass? So we tempered part of the samples to see, can we still maintain the effect of increasing the strength, and what magnitudes can we actually receive? Okay, and I will give you an insight on this today. So let's start with the thickness. So we produced samples 600 millimeters wide, 120 millimeters wide, so just some stripes of glass. And we designed a small test rig to measure the actual thickness of the glass along the whole surface. And we used glass with a nominal thickness of 2 millimeters, so quite thin glass. And probably everybody knows what is the tolerable thickness when you have 2 millimeter thick glass. What's in the code? Say again? 0.2 millimeters. 0.2 millimeters, that's correct. So plus minus 10%. So good. Yeah. One of my team members, so we prepared this perfectly. So we have 0.2 millimeters. And of course, you know, when you buy float glass, you will find actual thicknesses very close to the lower limit of the tolerable thickness. Okay, but what do we find with mouth-blown glass? And well, it's after lunch, so I'm asking everybody to vote on what value will we actually find. So please, everybody stand up. Everybody, even last rows, please. Okay, for float glass, it's plus minus 10%, so plus minus 0.2. Please sit down if you think it's plus minus 5% that you actually measure. So plus minus 0.1 millimeter. Nobody? One, okay. Do we actually measure those 10% plus minus? Okay, some people more sitting or getting tired, depends. What do you think? 15%? Okay, some more. There are some brave ones still standing. Plus minus 20%? Okay. Plus minus 30%, so plus minus 0.5 millimeters. Okay, there are 4.5. Okay, click more plus minus 50. Okay, it's increasing a bit right now. Okay. Okay, one left. Plus minus 75%. Okay, so you get an indication, right, what your feeling is of what you find. Plus minus 100%, of course, this doesn't make sense, so I cancel this out. What you actually measured for 2 millimeter thick glass was a variation between 3.5 millimeters and 1.35 millimeters. So I think this is quite excessive, especially when you recognize the values you see with float glass. And as we did measurement along the full surface, so we have this grid of 120 by 600 millimeters, we usually find, well, lots of values, and they are mostly homogeneous. So you will find samples that are quite thick, you will find samples that are quite thin, but what we also recognize that sometimes there is a pattern. So we find samples that will change their thickness, especially also in a very small distance. So we'll find samples that are really thin on one side and really thick on the other side. So just within 600 millimeters, you will find a change in thickness of 0.6, 0.7%. So this is realistic for mouth-blown glass. And of course, the reason for this is, well, the technique the glass is produced. It's a traditional technique. The glass is in contact with a surface while it's being blown to a large cylinder. And I think you have to keep this in mind. When you know how the glass is produced, you probably know lots about the characteristics of glass. Next question. After knowing the thickness, we asked, okay, can we thermally temper the glass? So half of the samples were put into a tempering furnace and were thermally treated, hoping to get something that might be fully tempered glass. And you see from those images, well, we can obtain a change in the glass. So we can see that we can put a pre-stress in the glass. And of course, we measured this pre-stress also for 15 samples, so those are all the results here, and we plotted the mean values as well as the spread within single samples, and you see there is quite a variation. The smallest mean pre-stress around 60 megapascal in compression on the surface, while the largest one was somewhere in the area of 110 megapascals, so we will also find quite a large variation. Reason for the variation might be the thickness. So we printed the thickness versus the surface compression. And this is what we found. So on the horizontal axis, you find the thickness, almost 3 millimeters to 1.3 millimeters. So this is the average thickness per specimen versus the surface compression. And you see quite a nice linear correlation between those values. So the reason we find different or quite a spread in surface compression is most certainly caused by the actual tremendous change in thickness, and the correlation coefficient is quite high, almost 80%. So this model works quite well. Next question is then, do we actually can reproduce this when we're looking into the strength of the samples? So when we are testing thick samples, will we find larger strength compared with samples that are a bit thinner? And here are the results for the strength in a 4-point bending configuration. On the left-hand side, this is the results for the strength of the annealed or non-tempered glass samples. So we have a characteristic value of about 48 megapascals, which I think is a quite good value, especially when you look into the fact that this is, say, annealed glass. So the edge treatment was well, really precise and quite nicely. Turned out to be nice results, but we didn't find any significant correlation when you look at the thickness here. On the other hand, after thermal treatment, you find the values here on the right-hand side. Again, there is no correlation with thickness, so the surface compression does not reflect in the strength of those samples, and we find a characteristic value of about 110 megapascal. So we didn't actually achieve something we would like to see for fully tempered float glass. But this just gives us an indication that we can almost use this mouth-blown glass in a comparative way as we would use annealed float glass, but we do not achieve the actual strength values of fully tempered glass. And of course, when we talk about those two glass types, we also have to look into the breakage pattern. On the top, we have a sample for the float glass, and I think we see what we expected. This is a float glass sample. It broke right here at the edge with a typical fracture pattern. On the bottom, this is a sample of a tempered glass. You see, well, of course, this is not a traditional fracture pattern test. It's after mechanical testing. So, of course, we have really small fragments right here in the center where we have the largest load and the largest mechanical energy. But I want to draw your attention to the left-hand side. So this is the end of the sample where the bearing actually was. And you see, we do not have the small fragments we would like to see with fully tempered glass. There are some larger fragments in there. So by tempering mouth-blown glass, we do not receive the fully tempered glass strength, and we do not receive the actually intended breakage pattern we want to have, just as an indication for using those materials. And as a summary, of course, we want to look into those products in a historical context for refurbishing heritage buildings. We found, as expected, a variation in thickness, and now we have some values we can use to play with, especially when we look into pre-stress and pre-treatment of the glass, because, well, the engineering heart or the heart of a structural engineer would like to engineer a product like this and needs, of course, some values to do so. And in the end, of course, there needs to be a disclaimer. We are looking not into float glass anymore. I think many of you have seen a float glass plant, which is quite impressive, but traditionally produced mouth-blown glass is more like a craftsmanship. And we want to preserve not only the historical buildings and the historical facades, but also, I think, the craftsmanship behind it. And we have to keep in mind that we are not looking at this kind of product from today's perspective. But also, when we look into the past, when in earlier times when your window broke, because of course notoriously kids play soccer, or around here they might play hockey, of course some glass breaks. What did you do? You brought your window to your local glazing shop, or you asked the guy to come around to replace it. And of course, well, the residual material was just stored in the shop, and when you need a piece of glass like this, well, the guy just looked into what is on stock, used a sample, cut it in correct size, and put it in, which is nothing less than we try to reproduce today. It's a reuse case where we are storing all the material in a certain place and waiting for a good opportunity just to reuse it. So I think we can learn a lot, not only from the craftsmanship, but also from the processes behind it in gaining some glass from the existing stock without reproducing it anew. And of course, if you want to follow up with the results I just presented you, just follow us on our channels, and I hope in the near future I can present some more in-depth results on this. Thank you very much.